Good morning, everyone. This is Shauna, and I'm here today to present a problem about the empirical rule and hopefully help you to derive the percentages on the curve for the empirical rule, and also to help you to answer some questions about the empirical rule. We'll be doing more of this in chapter 6, but if you're seeing this as you've only studied chapter 3, it will look more familiar to you later. So let me share the screen at this time and present the problem that I'm talking about. Let me drag this over some. Suppose that a standard intelligence test is designed to follow a bell-shaped normal distribution with a mean of 100 and a standard deviation of 15. I want to point out that when you see this word bell-shaped, or when you see the word normal, you'll see the word normal more in chapter 6 and onward after that. But up until then, you see bell-shaped. If you see the word normal, think about the bell. That's the shape of the distribution. So here the mean is 100, the standard deviation is 15. So what that tells us is that we have a curve, and you'll have to bear with my art a bit here, but we have a curve. Normally, the way you want to do this is draw a straight line somewhere in the middle of your paper like this, and leave yourself some space, folks. Now, when you draw the bell curve, sometimes that's a little tricky for people. What I normally do, start at the right and go up like this. You come to a peak, you come down, and then you make it flat like that. It's not the best curve, but it's the best I can do on the screen. Now, that's our bell curve. Now, this bell curve has some properties, and you'll learn about more of them later. But for now, this is what we're going to do. I'm going to draw a line in the middle of my curve here. That middle portion is going to divide the curve into 50% and 50%, because altogether we have 100%. Okay. So what I know is that my mean is 100. So I'm going to put 100 in the middle here. Okay. Now, if you look at the directions for the prompt that I gave you, let's go back to that. It says, suppose that a standard intelligence test is designed to follow a bell-shaped normal distribution with a mean of 100 and a standard deviation of 15. Draw the curve, label the locations of 1, 2, and 3 standard deviations above and below the mean, as well as the appropriate percentages for each interval, and then use the graph to answer the following questions. Okay, we're going to answer the questions, but we're going to fill in the percentages first. So let me come back to this whiteboard idea here. Now, numbers that are to the right of the mean, just like a number line, are said to be above the mean. So numbers that are over on the right are above the mean, okay? Because remember, the mean or the average is in the middle. So this is the mean here. This is above the mean. And numbers that are on the left are below the mean, okay? They're lower, literally lower than the mean. So our standard deviation is 15. So what we're going to do here is we're going to draw some marks that are representative of where we are. So we're going to say we have a mark here, and I'm going to put another mark here. Whoops, not that long. I'm going to put a mark here, and I'll have to cheat a bit and turn it, and also lengthen it just a bit. There you go. And I'll put a mark here. Okay, something like this. So this is 3 standard deviations. Now I'm going to do the same thing on the other side. Try to make them uniform. This takes a little bit of practice to draw this, but you want to try and get this symmetric in the middle is what you want to try and do. So here you have the 3 standard deviations. Okay. Now, our standard deviation is 15. So this mark, the first mark on the right, is the mean plus 1 standard deviation. So literally, I'm going to say that this is 100 plus 15, which is 115. Okay, this is the mean, which I'm going to write as mu, which I'm going to use u because I don't have a mu on my keyboard. Okay, mu plus sigma, which I'm going to use O for, because again, I don't have the Greek letters on my keyboard. Here, I have, this is mu plus 2 sigma. Okay. This little, this is 2 sigma. Okay. And the third one, obviously, is mu plus 3 sigma. And I'll do the math for you in a minute. But this is mu. Excuse me, a little bit large right now. This is mu, oops, this is mu plus mu plus 3 sigma. So this is your 3 sigma. Now, this is going to be 15 more than the previous one. This is 130. And again, the last one is 30 more than the previous. So this is 145. Okay. And we have the same thing going on the left, except that we're going to be subtracting from the mean because we're smaller. Mu minus sigma, mu minus 2 sigma, and mu minus 3 sigma. This is mu minus 3 sigma. Okay. Now, if I take 100 and I subtract 15, 100 minus 15 is 85. Because remember, I was given that the mean is 100 and the standard deviation sigma, which I'm going to represent with an O, is 15. Okay. So these are all segments. I'll put a little line over it. So it's like it's supposed to be. Okay. These are all sigma. Now, going to continue with my numbers. 85 minus 15 is going to be 70. And 70 minus 15 is 55. Now, you can also do the math. So this is like, remember, mu is our mean. This is equal to mu, right? And so this is our standard deviation here. So now we've got our numbers done there. Now I'm going to do my percentages. Now, if you remember from the empirical rule that we learned, the empirical rule says that 68% of the data lies within one standard deviation of the mean. So here, I'm going to erase these elements temporarily, okay? To erase them so that we can put in the percentages. Now, by the empirical rule, by the empirical rule here, there we go. We know that from before, we know that the empirical rule says, empirical rule applies to bell-shaped curves. And it says that approximately 68% of the data lie within one standard deviation of the mean. Okay, that's the first part, what it says. There are 3 parts to the empirical rule, okay? But this is the first part, that 68% lies within one standard deviation of the mean. So that means for us here that if I look at my picture that I have now, that between 85, let me switch colors here. My apologies. Let me undo the red mark. Between 85 there and 115, about 68% of my data is going to fall in here. Now, obviously, this is a bell curve. And so if 68, you've got this line, this black line right in the middle of it. So I'm going to take 68, or you can use the decimal 0.68, but I'm going to take 68 and divide that by 2. That's going to give me 34. Now, what this means is that this area on the left, okay, is going to be 34%. Okay, so I have this is a 34% of my results. This is another 34%. And the rest of this curve follows similar symmetry, okay? Now we're gonna do 2 standard deviations because the empirical rule says something about that. I'll put that in a green line here. So I'm gonna draw, and I'm going to change colors once again. There we go. So now here I am at 2 standard deviations between the green lines, 70 and 130. Now notice that this green area takes in this red zone, but we have these other pieces that we haven't yet filled in. So what I'm going to do is between the green, between 70 and 130, what it says is that there's approximately 95% of my data. 95% of the data lie within 2 standard deviations of the mean. Okay, that's this. 95% of the data lie within 2 standard deviations of the mean. So that's the green on your picture. Now, how do we get this percentage here in this white area and this percentage here? We know this is 68. We know the green area here from 70, in this case, from 70 to 130, from 2 standard deviations, right? How do we get that? Well, what we do is we say, all right, well, I know that I have 95, right? So I take 95 and I subtract this red piece out, minus 68. Let me, hold on here. I don't want to do that. I want to do this in 3. 95 minus 68. That's going to give us, if I subtract 95 minus 68, I get 27. Okay, that's 27%. Now, if I take, now notice that I've got an area on the left here and one on the right. So this area on the left plus this area on the right is 27. So I have to split them apart. This is, so I'm going to do the same thing I did here. I'm going to take 27 and divide that by 2. So 27 divided by 2 is 13 and a half. Okay, so then that means that this area here is 13 and a half units, or 13.5%, I should say. That's 13.5%. And so is this other area here on the other side, this corresponding piece of area here, okay? Now, if you take those 4 areas, we now have accounted for 95% of the data, but we still have a couple of sections here, all right? So we're going to deal with one more piece of the empirical rule. And I'll do that one in a, in a purple color here. It says that The third piece of the empirical rule says that approximately 99.7% of the data lie within 3 standard deviations of the mean. Now, okay, so now what we're looking at is we're looking at this here. So we're going to draw this line. Oops. Except I don't want it in green. I want it in purple. So let me put it in purple for you here. All right. So this is our purple line right here. Now, this is supposed to be 99.7. Well, I know all of my other percentages. So I'm going to do something similar to what I did with the green. I'm going to say 99.7. 99.7 minus 95. That's going to be a difference of 4.7%. Okay, this is 4.7. Okay. Now I'm going to take that difference, and again, I've got it on both sides of my curve, so I'm going to take this 4.7 and divide that in half. 4.7 divided in half comes out to 2.35%. Okay, so in this case, I've got this percentage here is going to be, let me see if I can squeeze it in here. This is 2.35. And on the other side, I have between the green and the purple line, I have 2.35%. Okay. Now we've got a little tiny piece left over. This should be percent. Poke that in there. Okay. All right. So now, okay, we have this piece on the end in the tail. We've only accounted for 99.7% of the data. We know that we need 100% for the whole diagram, right? So what I'm going to do here is I'm going to do one final calculation, and I'll do it on the bottom. I'll do it in this rust color down here. We're say 100 minus 99.7 gives us 0.3. This is equal to 0.3. Okay, the 0.3%. Okay, now I'm going to divide this in half, just like before. 0.3 divided by 2 is going to give me 0.015. 1, 5. This is 3/10. If I divide that, gives me this is so this is my, okay. Now, if I take, let me stop sharing for a second here. And I'm going to bring, I want to show you something about the decimal procedures for this, because sometimes it's easier to do the calculations with the without the decimal in there. But let me bring up the calculator. Give me a moment here to bring this up for you. So now I'm going to go to my screen here, and I'm going to share my screen. And you should see on the screen, I have, let me clear this. I have 0.3 dividing it by 2. And that's going to give me 0.15, okay, 1500. So now what I'm going to end up with is I'm going to end up with, in my text box, this is 0.15%. Now, if you do this in percentages, that's how this comes out. This is 0.15%, but you have to have the percent. Now, if you want the decimal equivalence of this, remember you get rid of the percent sign, and you divide by 100. So let me put this up a little bit more so you can see. This is 0.15%. Now, okay, so what do we do with our percentages? If these are decimals, then this becomes 0.34 without the percent, 0.34, and so forth, okay? But these are the empirical rules, the empirical rule with the percentages. And let me finish this answer, which I didn't type in. I gave it to you, but I didn't put it in there. This is 0.15%. Now, that's my percentages, and that's how they're derived, okay? So I hope that has been helpful to you. In my next video, I'm going to use this whiteboard to answer some questions about what we can do with these percentages. So let me pause the video at this time. Save the whiteboards for you. And I will see you guys on the flip side in my next video. Welcome back to part 2 of this video, where I show you how to use the whiteboard that we derived to answer some questions about the percentages of people that we can expect in specific groups, people or objects. So let me remind you here of the application from the previous video. Suppose that a standard intelligence test is designed to follow a bell-shaped normal distribution with a mean of 100 and a standard deviation of 15. Draw the curve, label the locations of 1, 2, and 3 standard deviations above and below the mean, as well as the appropriate percentages for each interval. Use the graph to answer the following questions. Okay. What percentage of people has an IQ less than 70? That's the first question. All right. So let me go to the whiteboard at this time, so we can remember, for those of you who were in part 1, but it may have been a minute since you've seen it. Let me show you that. All right. So here's our distribution. And for the sake of time, I'm not going to redraw it. I'm just going to add another whiteboard here and refer back to the distribution that I drew. So the first question that we want to answer is A. Let me use black. A is what percentage has an IQ or a score here less than 70? Well, let's look at our distribution. Let's go back. So 70, as we can see here, and let me do something down here, because I think I indicated that I was going to put it back for you and I never did, which is the area, like the multiples of the standard deviation. So this is mu minus 3 sigma. Then this is 70 is mu minus 2 sigma. 85 is mu minus sigma. The mean here is mu. Okay. Then you have 115. So mu is 100. So let me move that over slightly. There we go. 115 is mu plus 1 sigma. So this is mu plus 1 sigma here. And then we have mu plus 2 sigma here. And we have mu plus 3 sigma over here. So this is mu plus 3 sigma, okay? And I'm going to just drop this down slightly, if I can. There we go. Okay, so when you draw your graph, be sure you include the multiples of the mean minus 3 sigma, mu minus 2 sigma, mu minus sigma, mu, and so forth. That's part of the graph. The numbers, if you have them, sometimes you won't have them. Sometimes she'll just say, give me the bell-shaped curve with the percentages. In this case, you won't have numbers like this. You'll just write mu minus 3 sigma all the way to mu plus 3 sigma, but these percentages will always be the same.